This video is a follow-up from the video on types of flight. Here we'll be taking a further look at airships. Specifically, this will be an introduction to airships. I can't possibly cover everything related to it in one video, but this will be an introductory look at them. I'm sure most of you already know what an airship is. You might have seen advertising blimps or old photos of them. They were used around the First World War and up to the Second World War in some cases for certain purposes. Some of you might have encountered the Hindenburg disaster in your physics lesson about electricity, probably because that's how I came across it. So, yeah, that's an airship. As for the drawing here, I did that. So the links to the drawing in the description below. Airships are a pretty interesting topic because they are kind of making a comeback. The main reason is because they're almost ridiculously efficient in terms of energy requirement compared to other flying machines. What's making a comeback specifically is hybrid airships. Talk about that in more detail later, but what we're looking at here is the traditional type, basically the one that uses a lifting gas to fly. The hybrid airship uses the shape of the ship itself to generate lift as well, in addition to the gas. So here we'll be looking at the traditional type mostly. So let's start by looking at a diagram. This one. So when you look at the diagram, you see a big balloon-like structure on top. That's the envelope. It's usually filled with a gas that is lighter than air, and that is what keeps the airship airborne. So the gas is called the lifting gas. So what happens is because it's lighter than air, and because there's such a lot of it relative to the rest of the structure, it makes the overall airship, the overall structure of the airship, less dense than the air around it. So that means by Archimedes' principle, basically, it experiences an upthrust because the air it displaces is heavier than the weight of the structure itself. So the net result is it experiences an upthrust. So this net upwards force will make it accelerate upwards, as in it will make it fly up. And when the upthrust is equal to weight, it will float there. Why that happens is because air gets less dense with altitude, and you will eventually reach an altitude where the upthrust that the airship experiences is the same as its weight. So when it comes to that point, it's not going to keep moving upwards, and that will be the altitude at which your airship floats. So as you may have imagined, how you control the altitude at which it floats is basically by changing the density of the airship. So you could do that by dropping some weight, as in you may have basalt on board, you can drop that to reduce your weight, or you could release some of the lifting gas. So the lifting gas itself is usually helium on modern airships. It's very light, it's the second lightest gas available, and it's extremely safe. It's non-flammable, it doesn't react with anything, but the problem is the helium supply is limited, so as a result, it tends to be quite expensive. Hydrogen has also been used historically, mostly because it's the lightest gas available to us. But the problem is hydrogen can be flammable when mixed with air. So if the envelope leaks for some reason and something sets the mixture of hydrogen and air, essentially hydrogen and oxygen, on fire, then the whole airship could burn up potentially. But the pure hydrogen is not flammable, so even if you have an envelope filled with pure hydrogen, if you have a spark inside it, nothing will happen. But the problem is preventing leaks completely on a moving ship that's mostly made of a flexible thin exterior can be pretty impossible. That's why it's not used in great quantities anymore for passenger transport, at least. Another option is hot air. So in this method, you can use a burner to heat air inside the envelope. Think of a hot air balloon. Since air expands when it's heated, it reduces the density of the air, so that makes it lighter than the air outside the envelope. So the advantage here is air is not a limited resource, and also the lifting gas itself is not flammable. The air itself is not flammable. The problem here is that you need to carry a fuel supply for heating air. So you could burn something like kerosene, or you can use electric heaters. The problem here is that fuel weight can become significant. This will be true for batteries or even if you use solar panels for the purpose. They also add a lot of weight. And if you burn your fuel as you travel, you're losing fuel weight, maybe significantly. So you'll have to compensate for the weight loss when flying. Besides, the fuel itself can be a fire hazard, or in the case of batteries, depending on the type of battery, it could even be explosive. But overall, it's a happy medium. So if you're using this for a writing project, you can always make up a lifting gas. I mean, provided it's fantasy or even science fiction. And you can create the properties of the gas, its availability, its price, all that. You can use that for world building. And another possibility is to use a vacuum. This will lift the airship all right, but the envelope will have to be very strong. Realistically speaking, impossibly strong. And altitude control will be a bit of a problem. So I will probably discuss this hypothetical scenario in detail later. So going back to the diagram, you will see a small section at the bottom of the envelope. That is your gondola. That is basically where you have your passengers, your crew, your storage, fuel, whatever instrumentation, everything. And it can be quite roomy for the number of passengers it can carry compared to a modern airliner, mostly because it needs to maintain a pretty low weight. On a particularly large airship, you may need to figure out some means of communication between different areas in the gondola because it can get that big. So think of it like something that's a bit similar to a ship. Also on the diagram are engines, and these are what provides power for forward motion. Usually they would be fitted with a propeller because few other types of propulsion actually make sense at the speed at which an airship flies. The actual engine type, as in the engine that's attached to the propeller, can be pretty much anything you'd see on a propeller driven plane. So in an airship, the engines are usually fitted to the sides of the gondola to allow differential thrust for steering. Many also have rudders, but you can use differential thrust as well. The fuel for these engines can be pretty much anything. So you could use an electric motor, you could power it using a battery or even solar power, or you could use a conventional fuel like diesel, petrol, whatever. Anything will work. In addition to that, an airship can have a vertical stabilizer and a rudder, so that may depend on the purpose of the airship as well, whether it has those. And it may also have horizontal stabilizers and elevators. So the function of these will also be material for a later video. This is one of my favorite areas, so I could talk on this for hours, but it will be in a later video. So, talking about airships, the main disadvantages compared to a conventional airplane are the lower speeds. This is mostly because the envelope is enormous, especially in terms of cross section, and that produces a lot of drag. So, that means the top speed is pretty limited. Another possible problem is the lower service ceiling in general. This is dependent on the difference in density between the lifting gas and the surrounding air and how much lifting gas there is compared to the rest of the ship and such. So overall, the service ceiling is capped by the possible size of the envelope. So you could say the square cube law also factors into this. Another possible disadvantage is the properties of the lifting gas. It could make it a fire hazard, but that depends on the lifting gas you use. And if you're going to use this in a combat situation, another possible issue is it's a huge, slow moving target. And this can be especially dangerous if the lifting gas you're using is flammable. A pretty big disadvantage is because of its size and because of its slow movement, it can be a bit susceptible to weather, as in winds, possibly even lightning. So that's one of the disadvantages. So when it comes to advantages, the main advantage is the lower fuel requirement compared to airplanes and almost any other type of flight because you don't need energy to provide lift under most circumstances. The exception is, of course, hot air. Another advantage is you can stay airborne pretty much forever. There will be some gas leakage, and the leakage will make the envelope deflate over time, but still you can stay aloft for a very long time. And as a result, it's pretty great for sightseeing and observation. Another advantage due to the sheer size of the envelope is that it can't be brought down so easily by enemy fire unless the envelope catches on fire. So, for example, if you put a bullet hole in it, the hole is so small compared to the rest of the envelope that it will take a few hours for it to deflate completely. So, that will give enough time for a safe landing. Another possible advantage is if you use it for passenger transport, the sheer amount of space on it is very large compared to an airliner. So, what this means in practice is instead of being cramped into a seat for 8 hours, you can walk around, sleep, eat, and maybe enjoy the view for 2 days. So, it's up to you to decide whether it's actually an advantage. So, that's it for a brief introduction to airships. And I promise I'll follow up on everything I said I'll follow up on. But that's all for this time. See you next time.